Thank you. Okay. So my name is Aaron Krauss. Thank you for the lovely introduction, Carson. I have been a programmer for a while now. I think 9 years or so experience. And I'm going to talk today about just an intro to programming. Now I've kind of got some topics here that I'm going to talk about. We'll do a little abstract here in a second. But if you guys have any questions about anything, even if it's not related to anything that I'm talking about, shout them out. Raise your hand just so we're not interrupting anyone. But feel free to ask anything at all, and we'll have some time at the end too for you to ask questions as well. But I want this to be fun. I want it to be interactive. Throw anything that you have at me. Okay, so that's me. I'm the code boss on Twitter. Feel free to, if you think of a question tomorrow or the next week, hit me up on Twitter. I'm usually pretty active there. So I work at a company called Clevyr. It's spelled just like the word clever, but the last E is actually a Y because we're clever like that. We are a development shop. We're very close to here. We're about a mile up the road, just off of Classen and 9th Street. We build web applications, mobile applications. We'll build anything from a marketing site, a simple little static page. We'll review what that means here in a minute, to really dynamic applications. Think Facebook, but probably not a scale of that, but things like that. We like to have fun. We're pretty small. We're about 12 people right now. We've been around since 2009. But if you have any questions about what I do at Clevyr, again, feel free to hit me up. This is our cool gear logo. So this is what we're going to talk about today. I'm going to give you a brief intro of my day-to-day, what it's like to be a developer, some different languages, kind of when you would use them, depending on how deep you are down the programming rabbit hole. You may have heard of 1 or 2 languages. You may have heard of 20 or 30, and there's plenty more than that. So I'm going to talk about some of the common ones and why you would use them. I'm going to talk about what it's like to code in a team. It's a little bit different than just coding by yourself. Some of the basics of programming that most likely every language you ever deal with will have. And then kind of the different types of programming, and we'll have some code examples there. So let's just segue into it. So my day-to-day is I check email and I check Slack when I get in. Slack, I'm sure most of us are aware, the instant messaging application. We use that at Clevyr quite a bit. Then I code, and I have X amount of projects I'm working on at all times, but this is mostly just me in the zone working on projects on this machine right here, and that's it. I usually have a cup of tea with me, but that's it. I'm just sitting down coding, and then I play ping pong because I like ping pong. We have a ping pong table at work, and then I do more coding, and this is more or less my day right here. I do have the occasional meeting. This will depend on where you work, how many meetings you have. They will happen. I'm sorry, meetings will always happen. But Clevyr keeps us pretty safe from all that. I'm talking maybe, a little internal meeting is a little bit different. I'm kind of thinking of this as a meeting with a client, maybe once a week or something, if that. Again, it depends on where you work. But that's really it for me. I code most of the day. And to someone who may not be a full-time developer or part-time developer, that probably sounds weird to think of you're just coding all day. How do you know what to work on? And again, this is kind of job specific, but the way I explain it is you start at a place and you will get one project. And your bosses will kind of see how you do with that one project. And then you'll be working on that one project over a week, and then you'll land another project. And now you kind of have to siphon your time between one project or 2 projects. Then maybe you finish project 1, and then you'll start project 3, and then maybe before you finish any of those 2 projects, you'll be given another project, and it kind of becomes this balancing act. But after a month or 2 of working at a place, you're pretty much always you know what you're doing. You know what projects you need to be working on, so you're always kind of just balancing that. So that's what I mean when I'm saying I'm coding. I have X amount of projects that I'm working on at all times, and they change quite a bit. But I'm just in the zone on this laptop. 7 hours of the 8-hour workday. Otherwise, I'm playing ping pong, making tea, having fun with coworkers. So when I say code, I'm not just this genius machine in here just dishing out awesome code all day long. When I say I'm coding, I mean I'm doing a lot of Googling. That's truly what coding is. If we didn't have Stack Overflow or whatever forum is your favorite, I would be out of a job, for real. There's just, you know, anything that I'm doing, I'm going to always Google up what's the best way to do this. Even if it would take me, even if I could find a way to do it in an hour or so, someone's going to have found a way to do it better than I can. And coding to me is kind of more assembling different ways to do things. We don't need to reinvent the wheel for every project. So, and there's just a lot of things that I just flat out don't know, and that's normal for a developer. I think it might be a little overwhelming if you ever hear developers talk and they act like they're super smart. I hear them talk, people who are my same level, and I just think they're light years ahead of me. But we're just good at Googling. We're not brainiacs, we're not geniuses, and that's okay. I don't know the answers most of the time. So I just wanted to make that clear. Being a developer doesn't mean you're awesome at everything. It means you know how to research on the internet. That's really what it is. So I want to segue into kind of when you would use different languages. JavaScript is probably one that we've heard of quite a bit. I'm going to do some code examples with that later today. But there's plenty more out there, and I'm sure you've heard of a bunch of other ones, or maybe you haven't, but you're going to hear about them now. So I kind of separate languages into different realms of what you would actually use them for, and I like to think of it in these 4 realms: software development, web development, mobile development, and game development. There's probably some other minute ones I'm missing, but this is a good way for me to categorize it. So we're going to go down the list here. When I think of software development, that's kind of, it's the oldest realm of developing. You're building actual applications that live on your computer, someone else's computer, a server somewhere, but they're not necessarily, they may or may not be connected to the internet. Just think of a calculator application on your computer. That's a software application. These have been around for a long time, since programming has kind of started really ramping up since the 50s or so. And the languages that you would really use for software development are this is an example of some of the common ones. This is by no means an extensive list, and none of this will be an extensive list, but some of the common ones you may or may not have heard of are C or C++, Java, C#, Go is a newer one, and Python. There's plenty of other ones. You can use JavaScript to write a software application. You can use Ruby to write a software application. But these are the big ones that you would find. If someone is hiring for a Java developer, for example, you may be working with the web, or you may just be working on an existing software application. Python and Java are probably the biggest things you'll learn if you learn programming the classical way in college and high school and everything. Maybe you'll probably touch some C as well. But again, those are really good languages to learn and get ramped up on. And this is where you may use them, but it's not an extensive list. These are just these are kind of where you might use these languages. And you're going to see some crossover here when I list web and game and mobile languages too. So web development. This one we're going to talk about probably the most, because this is if you get a job as a developer, it's more than likely going to be a web developer. That's where most jobs are, and it's probably the easiest to get ramped up on because the internet is ubiquitous. Everyone wants a website. Everyone wants a web application. And honestly, even if you're building a software application, nowadays that's going to tie into the web somehow, so you're probably going to build a website for it, etc. A lot of things come back to web development. So web development is kind of branched into 2 different areas. You can build static websites, or you can build dynamic websites. So I'm going to get into what that actually means. Let's start off with static websites, because these are a little bit easier to understand. When I'm talking about a static website, I'm talking about a website. This is an example of a static website. It's just a page where I have some projects listed. Whether you go to this page, or I go to this page, or someone else goes to this web page, it's always going to be the same. Nothing's changing on it. And that probably sounds weird, because most websites you probably think don't change. But I would argue against that, because think about it. If I log into my bank's website, and you log into, let's say we have the same bank with you log in with your credentials, ideally our money, whenever we actually get into the account, is probably going to be different. If it's not, then that's just a super cool coincidence, or something's wrong with the bank's website. But that's an example of a dynamic website, where we may be at the same URL, but things are different on the web page. Think Facebook, think Twitter. Banks are a good thing. Anything that you really, if you have to log into it, that's more than likely a good clue that it's a dynamic website. You don't have to log into it, though, for it to be a dynamic. It can be any website where something is changing or potentially is changing. So, and again, I know this might sound confusing, so I really want to encourage anyone to ask questions. But let's get into what actual languages you would use for a static website. Well, there's only three, and that kind of makes it fun and easy to understand. You have HTML, CSS, and JavaScript, and arguably only one of these is an actual programming language. Anyone care to guess? It's this last one right here, JavaScript. HTML is strictly how this page looks, and we can actually take a dig into this. A lot of you are probably seeing this, maybe you've messed with it, but this right here, this is all HTML. It stands for Hypertext Markup Language. These are all just tags. So that's just HTML, no programming. You're just laying out the content of a page. CSS is how you make it look pretty. So for example, going back to this demo, all these things right here, saying padding, giving a little border bottom, a box shadow on whatever this div is right here, that's all CSS. We're just making it look pretty. It's not a programming language, it's a styling language is what it's called. CSS stands for Cascading Style Sheets. And the JavaScript is where you can actually make things do things. So for example, if I don't even know if I have a ton of JavaScript on here, but if I, for example, wanted to press this button and have a pop-up that did something, that's JavaScript. And I'm sure a lot of us have messed with it. I won't spend too deep into that, but if you're building a static website like this one, where things just aren't changing, you will only use these three technologies. And these are, for anyone really new to programming, this is what I would want to recommend you, kind of a personal recommendation. I think this is an awesome place to start because there's not a ton of stuff to learn. You can get down the rabbit hole and you can, especially with JavaScript, you can get really deep in it and do a lot of cool stuff like building web games if you want to. We'll get into that in a second. But this is a wonderful place to start if you just wanted to build a website that just said, hi, my name is this, and put it on the internet. That's a wonderful way to get started. And it's actually, you can show it to your mom. Show mom, I did this. Okay, so I've mentioned static web pages, and if someone is saying that they're a front-end developer compared to a back-end developer, they're typically referring to, they don't have to be referring to static web pages, but they're usually referring to dealing with these three languages. Largely JavaScript. This will be, if someone's saying they're a front-end developer, that usually means they're dealing with a lot of JavaScript. But it also will typically mean that they deal with, at the very least, HTML. CSS, front-end developers can be variously skilled in CSS. That's kind of it's more of a designy type language. But some developers are great at it. Other front-end developers, it just isn't their thing, and that's totally fine. But it will mean that you're good at JavaScript and probably at least proficient at HTML. Back-end languages, for example, I like to think of it as pretty much everything else. There's a ton of other languages. These are strictly front-end languages. Back-end's going to be everything else. So let's talk about dynamic websites. Well, I kind of mentioned that, Facebook, Twitter, banks' websites, there's a ton more. But any website that you really interact with a lot, and it involves data. If it involves data of any kind, and I'm not talking about numbers necessarily or science things, but you post a tweet, you create a Facebook status update. That's data that's stored somewhere. That's going to be a dynamic website. And these languages are going to, these websites will always use, going back a couple slides, it will always use these languages at the very least. But then you need to tie it with other languages that are called server-side languages or back-end languages. Those are the same things. So use those same languages, HTML, CSS, and JavaScript. But you can also use something else. And again, this is not an extensive list. And you see JavaScript pops up here again. I don't know if we've had much experience with Node.js here, or if any of you have. Node.js is JavaScript, but it's just JavaScript that is run as a back-end version, as a back-end language or a server-side language. The same thing in this context. But you can use PHP, Python, Ruby, or C#. These are just examples of the common ones. You'll remember Python and C# kind of popped up earlier when we were talking about software development. There's a lot of crossover, especially with JavaScript and C# as well. But these are the languages that will do things like interact with the database, so they can pull, your previous tweets, your previous Facebook status updates, your financial information with your bank, and then they will basically generate the HTML that has that information on it. So these are the languages that do the heavy lifting of interacting with data of any kind, and that's how you make a dynamic web page. So, and again, not an extensive list. There's a significant amount of other languages, but these are probably going to be the most popular ones that you'll see about. I'm trying to kind of stick with top 10 languages or so, because like I said, there's easily hundreds of languages out there, but let's face it, you're never going to need to know 95% of them, because there's about 10 or 20 that we really use heavily today. So that's kind of web development, and that's definitely the biggest area of development. And again, that's my humble opinion, and I think it's a wonderful place to start. And I think JavaScript is probably a big language that's focused on here, and I think that's definitely the best language to start with. So mobile development, well, we've got Swift. You may have heard of that. That's the iOS language. I think currently you can only build that on a Mac, which I think is dumb. Previously to Swift, all iOS applications were written in Objective-C. I hate that language so much. It's the ugliest thing I've ever seen. Humble opinion, I know. You can still write apps in Objective-C, and Swift can actually run Objective-C code, but Swift has been out for I think over 3 years now, so that's definitely the way to move forward. So if you wanted to get into iOS development, you have to learn Swift pretty much. Now that's not necessarily true. Let me segue into that here in a second. For Android applications, for native Android applications, they're written in Java, and that's what they've always been written in. So we saw Java creep up when we were talking about software applications. I didn't mention it with web development, but Java is a very big language for dynamic web pages. So for just like Ruby and PHP and the other languages we saw there. And it's coming up here with mobile development. So Java is not going away, no matter how much some of us would love it to. I'm not on the Java hate train, but I know it's anything old, any old technology, there's always haters. And Java has stood the test of time, just like C. Now, this last one here, HTML, CSS, and JavaScript, those are the static web page languages. There are technologies. PhoneGap is one that's called the big one, and that would be if you're interested in mobile development, I highly encourage you write that down and Google it later. Just PhoneGap, all one word. But that is a technology that allows you to build cross-platform mobile applications. I'm going to come back to what that means. With using these three technologies: HTML, CSS, and JavaScript. Languages that you have used for web development or will have used. You can use those same technologies to build mobile applications. Now, going back to the cross-platform, you may have already guessed it. That will just mean that instead of having to build an iOS version of your app and an Android version, you can use PhoneGap or just HTML, CSS, JavaScript, those technologies to build basically one copy of an app, and you can build it for iOS, and you can build it for Android. You can probably even build it for Windows Phone, even though I think they may have officially stopped supporting that. But that's a big area of development as well. Kind of comparing the two, you might wonder, why would I build a Swift app or a Java app if it's only going to work on one platform when I could build a cross-platform app using HTML, CSS, and JavaScript? Well, the big benefit you get with the native apps, the natively built apps, which are Swift and Java, are their performance. You just can't compete with it. If you're building a game, I'm trying to think of it, like an intensive graphics game, you probably can't get away with using HTML, CSS, and JavaScript. These kind of apps. The majority of apps you probably can. Think of Snapchat. You could probably build that. It may not be as fluid as theirs, because I'm sure theirs are native applications. But the idea behind that, where you're not moving around and there's not a lot of things changing all at once, you can stick with just HTML, CSS, and JavaScript. And that's another reason why I really promote learning these languages, especially JavaScript. It's a phenomenal language to start with, and it's super hot right now. Like everyone's been talking about it. The last area I'm going to talk about, make sure I'm doing good on time, is game development. And I'm sure I'm sure we're all kind of aspiring to be developers here. This was my reason I wanted to be a developer. I wanted to work for EA Games. I'm sure that's most people's original idea of being a developer, is to make some cool games. Clevyr actually does create some games. I'm not on that team, but I'm sure one day, perhaps, it's a dream. These are kind of the biggest languages right now in game development, and there's more than this, but these are the hot ones right now. And I think at this point we've seen them all creep up in the other things I've been talking about. We've got C#, and if anyone's heard of Unity, is the game engine I'm talking about here, that's all written in C#. You would use C# if you're building a Unity game. The Unreal engine, created from the Unreal series, Unreal Tournament, Unreal Championship, all that. That's all built using C++. So if you build a game using the Unreal engine, you'll be using C++. Those are, and both of these are cross-platform tools. So you code it once, and you can release it to Windows, Mac, Linux, mobile devices, the PS4, etc. You'll probably need to do small optimizations, for each one, but you're writing it once, not writing it 10 times for each thing. Now, I included JavaScript on here because, well, there's also web games. Previously, games were built using Flash. That's not really a thing anymore, so you don't have to worry about Flash. But JavaScript, if you're building a web game, a game that exists just on a website, you more than likely will use JavaScript to do that. So again, I think JavaScript has creeped up in all of these areas. So it's an awesome language to learn, and we're going to see some code examples of that later. I'm sure plenty of us have messed with it before. So I'm going to segue into my next section, coding in a team. Again, I encourage you to ask questions over anything I've talked about. So when we're coding in a team, it's different from coding just yourself. I kind of learned programming through school a little bit, and for me it was I would be given an assignment, I would be told to code this thing, and I would just turn it in, and that would be it. I wouldn't work with a partner, maybe on one project or so, but the vast majority of assignments, I wouldn't have a partner. I wouldn't really get much feedback from how my code was. I would just get a grade that said, you got an A, a B, C's and D's. Yeah, everybody gets them. It's not just me. But it's whenever now that I'm in a work environment, it's not so much about. Obviously, you want to write code that doesn't break, but it's not so much about how well you do things. The big thing is I'm never going to be the only developer on the things that I'm doing. I may be the only one developing it right now, but there's a chance that in 1, 2, 5, or 10 years, someone's going to be touching the code that I'm writing. And that may seem unfathomable, but I used to work at a company called Advotech up in Edmond, Oklahoma. We built software to kind of do auditing of loans and everything. It was a mortgage quality assurance company. And I was frequently editing code that was written in C that was created more than 20 years ago. So by people who weren't even alive anymore. It's a thing. When you write something, there's a very small chance that you will be the only one to ever mess with it. But you need to prepare for the code that you're writing to at least need to be readable by someone else. So that's the big key. Someone else needs to be able to go into your code and be able to understand what's going on. And given enough time, someone could do that no matter how poorly you write your code. But doing it better or doing it better from the start is a good way to do it. Yeah.
Wouldn't the opposite of that be for your own job security?
I've heard that argument before, where I've worked at places. I'm sorry. The question was, I'm going to repeat that, is what about job security? I think you meant it humorously, but it's definitely that is a thing where if you are kind of a sole developer who is the only one who knows the business logic, and every workplace usually has one of those people, then yeah, they're not going to want to fire you, that's for sure. But the ideal way for me to think about it is because you're promoting the business logic and you're helping out other developers by making your code readable, they're going to want to keep you. There's no reason for them to let you go, and that's how everyone's going to like you. So, but that's a good point. So one way, good question, by the way. So one way that you may have heard about that you can help developers understand your code is to use comments. Comments are just lines of non-editable, non-actual code. You're just saying, this is what I'm doing here. Use Whitespace. Now Whitespace is just the blank lines between code. It's indentation, those kinds of things, and we'll see a little bit more of this later. But this one might seem a little bit not as important, but my big thing here is if you have a lot of stuff that's happening, don't jam it all into one line. Don't put like X, semicolon, add this thing, semicolon, do this thing, semicolon. Don't put all these operations on one line, because that's going to make it very difficult for me to read. Space things out appropriately, indent things appropriately. If you're inside of an if block, ideally you would indent, just so I can grasp the concept of what's happening here. So using Whitespace appropriately is a very important thing. Name things appropriately. If I have a variable that is clearly a price of something, don't just name it X. Name it price of whatever the thing is, or something that indicates what's actually going on here. If you have a function that's adding, two items together, don't just name it do stuff or foo or anything like that. Again, given enough time, any developer can understand what's happening, but it's much easier if you name things appropriately for me to understand, because let's face it, we never have enough time to do the things we want to do. So naming things appropriately is really important. And the last thing is going to be the most confusing, and this is going to be one that I'm going to talk about and then encourage you to Google it. But version control is the idea of how we share code in a team environment. One thing about coding in a team that if you haven't thought about before, you may be kind of perplexed by it, but it is possible for me to work on not only the same project as another developer, but to actually edit the same file as another developer. And you might be thinking like, well, how's that work? We're going to override each other's changes. And if you didn't have something like version control, then you would easily do that. But the way version control works is I'm going to have this fancy little graphic that's pixelated. So we may or may not be able to read it, but the arrows are kind of the most important thing. Let's say I'm developer B right here, since it's got the words. We're working on the same project, and that's what this represents. It's kind of a central hub of our project. Well, whenever I make a change to this project, I'm going to use a version control tool to, the idea of version control is to track changes in your code. So when I make a change, it's tracked somewhere. If I delete a file, add a file, delete code inside of any file, etc., it's always tracked anywhere. Whenever let's say I add a line to a file, that's going to get tracked using version control, and then this arrow right here is going to be pushed up to the central repository, the central hub of our code. That's usually called a commit. And then what happens is, so let's say developer A is you, and you want to update your code with the update that I just made so that we're all kind of synced up, then you can pull down that change using the same version control tool. This tool allows us to push up our changes and pull them back down so that we can stay in sync. It's a lot better than doing things like emailing each other our code or chatting it to each other and saying, hey, change line 13 to this variable name instead of this. Version control tooling takes all of that, not away, but it makes it significantly easier. It does it all for you. You just have to issue the command that says, hey, I want to push this up, or hey, I want to pull down, all the changes that have been made. And all your code gets updated automatically. It's a very nice tool. I don't know if I have it listed here. Okay, Git is the most popular version control system. So VCS stands for. So Git, I think if you've been to some of these meetups before, I'm sure they've talked about Git. If you haven't heard of it or are new to it, I highly recommend you Google it. It's also, you may or may not have heard of github.com. That's a wonderful place to kind of start your coding journey. I'm sure many of you have accounts here. But that's where you can push your code up there, and you use the Git version control system to push your code up to GitHub. That's where the name comes from. It's a hub for your Git repositories. Okay, so segueing right into some programming basics. Again, feel free to throw out any questions you may have. So I'm going to briefly touch on things that pretty much all languages have, and I'm going to use JavaScript to do this. We have these kind of things that I know for a fact that every language has. This is going to be a little caveat here at the end, but we'll get into that in a second. Data types, whether I store, and that kind of goes with variables as well. If I'm creating a variable, it's going to have a type of some sort. An integer, a string, which is just like a little thing of characters. A name, for example, is a string. A character is a data type. And then I said integer, and then you can break that down into other number types too. You have floats, which are usually decimal data types. You have doubles, which are also decimal data types. I'm talking like 1.1, for example, versus 1, which would just be an integer. Different languages have different data types, but those are kind of some of the common ones. Every language is going to need to understand what you're talking about, and it does that at a rudimentary level using data types, assigning things to types. Variables, you're going to use variables of some sort. It's important to, and variables, I'm considering calling variables and constants kind of the same thing here. Whether or not you can change a variable is not what I'm talking about. I'm just meaning you're storing information in some thing to use later. So I'm setting this variable x equals to 1, even though I said earlier you should name things appropriately. A function is something that all languages will have. And you may find the one language that doesn't have functions, or the two languages that don't, but more or less you'll find these in 99% of all languages. A function is just, some languages call them methods, some will call them routines or subroutines. It's just a little place for you to put some code down, and then you can invoke the function or call it, and it will do things. We're going to see that later. And then loops are, this is kind of a caveat. There are a couple languages that don't have loops, but they have something like it called recursion. Every language will have recursion. We'll see an example of that later on. I'm not going to confuse anyone with that yet. But loops are just the idea of you're going to iterate through some block of code over and over again until some condition is met. It could be that you have a list or an array of X amount of items, and you're going to iterate through all of them, the length of the array, or let's say you are, adding up a variable every time the loop runs, and you want to run the loop until the variable gets to 20. That's an example of a loop. Every language will have some form of iteration, I should say. So let's do an actual demo of what this is. And again, I'm just going to use some simple JavaScript here. Now, my environment here is not super important, but in case you were wondering, these three files are the ones we're going to be looking at here throughout this presentation. And I'm using an editor called Vim. It's all through the command line, and that's what I'm in right now is the command line. So I'm going to close that side window. Can everyone see this all right? Okay, if I need to zoom in, feel free to let me know. So this is kind of an example of the four things I was just talking about, and we'll go through this slowly. I'm going to run this using Node. This is just plain JavaScript, but again, Node is kind of the back-end implementation of JavaScript that I don't need to be in a website to run. I can just run it from the console here. So we'll run it in a second. But what this is going to do is we're creating an array called list. So the data type is an array, and it's an array of integers. These are all integers here. And we're setting a variable. So we've already done two of those things I mentioned. Now, we have a function here that is going to do something whenever it's called. If we were running this code just from top to bottom, this code would not actually run at all until I actually call the function, which, it's going to happen right here on line 9 right here. I'm actually calling or invoking the function. So whenever this line gets called, it's going to run this function. And this is a for loop right here. So we're going to iterate through this code. This is an example of a loop. And we're going to create this variable I. I keep mentioning name things appropriately. I is kind of a standard of if you're just iterating through something. I usually refers to index. So if you just are tracking kind of an iteration, I is it's a coding standard to use that. But if I were to name list up here, for example, just X, if it were an actual important list of something, that would not be appropriate. You'll also notice I named the function print array, and that's what I'm doing. I'm console logging, which is printing to the console each element of the array. So it's more or less pretty clear what I'm doing. I didn't name the function just X. So I have a for loop here, which a for loop will just run whatever based on the conditions I give it. So I'm creating a variable here and setting it to 0, and then I'm going to run through this for loop as many times as it takes until I is just less than the length of this list, which the length of this list is 3. Don't look at the numbers inside of that to determine this. It depends on how many things are in it. So there's one thing here, there's another thing here, and there's another thing here. So there's list of 3, length of 3. And then we're incrementing, every time we run the loop, we're going to increment our I variable by 1. So this loop is going to run 3 times. I is going to be 0 the first time, it's going to be 1 the second time, it's going to be 2 the third time, and then whenever we try to run it again, it's going to be 3, but this condition right here is going to prevent it from actually being run because 3 is not less than the length of the list, which is also 3. So then we're just going to exit that loop, and then this function is going to be done. So let's actually run this. Let me do that over here. Okay, so I'm just going to run, let me go into that directory. So the file was called basics.js, and it's just going to print 1, 2, 3, which is what we kind of saw here. We're just iterating through the list, and we're just printing out each item. We ran through it 3 times, and that was it. So this is kind of an example, and if you've dabbled with programming before, I'm sure many of us have here, This may not look too complex, and that makes me happy because I'm trying to keep the concepts pretty simple. If this is your first time looking at JavaScript or programming in general, I'm sure this looks like mumbo jumbo. But it's a process, I promise. We all start somewhere. So this is an example of just some of the basics of programming, and this type of thing, you will do these types of things in just about any language you use. You'll use variables. You'll have data types. This right here is an integer data type, but I could have named this just a character right there, and that would be fine. They're just different data types. We have a looping structure of some sort. We're iterating through something, and then we have a function that's up here called printArray, and then down here we're just calling that function. These are things you'll do in just about any language. One of the things I like about JavaScript is I'm going to get into different types of programming here in a minute, but JavaScript kind of allows you to do things however you want to. Some developers love that, especially as you're learning. I think it's a great tool. Some developers hate it. Other languages like Ruby or Python, for example, even, they kind of stick with one way of doing things. And again, if you're a developer of that language, you might love it, but you might hate it too. JavaScript allows you to build things really however you want to, and I think you'll see that here in a little bit. So let's get into, I just brought open my menu back on the side here. We're going to look at these other files here in a second, but before I get into that, let's talk about what different types of programming there actually are. And there's a bunch of them, and it probably is confusing when I say different types of programming, but we'll get into some definitions here. I'm going to talk about the top 3 different types of programming that you can get into. Some developers will call them paradigms of programming. That can be a confusing word, just means the way you do something. I'm just going to stick with different types of programming. So these are the 3 that are, if you're going to get into development, these are pretty much going to make up the majority of languages you'll deal with. There are different types of programming, but this makes up the lion's share of everything. And I'm going to talk about procedural programming, object-oriented programming, which is the big one. That's what most development today, and for the last 20 years or so, has focused on object-oriented programming. This is what they teach in school. It's the big one. And then we're going to talk about functional programming, which has been around for a long time, a very long time, but it's really just getting popular recently, like within the last 10 years or so. It's been used it's used significantly in kind of science or mathematics backgrounds. It's based on mathematics, actually. But it's really getting popular now, and there's a reason for that too. So let's get into the oldest one of these 3, which is procedural programming. So procedural probably sounds one of the most vague, but these are some languages that are procedural languages, and they're all old languages, meaning like anywhere from I think these are all about 50, maybe 40 years old. I think Ada is about 40 years old. C has been around for almost 50 years now. Fortran's been around for right around that, I think a little bit more as well. Go is new. Go is a language created by Google in 2009. So it's the newest procedural language by far. And the whole idea of a procedural language is it's what you just saw, actually. That was all procedural code. The idea behind it is it just breaks code into procedures, which, like I said earlier, that's kind of a function as well. Languages will call them functions, procedures, methods, different things, but they're all just some enclosure of code that gets called to do things. It just allows you to kind of organize code. So this right here, as you can see, I've got some other files called functional.js and object-oriented.js, but I don't have a procedural one. Again, that's just because this right here is valid procedural code. We just took some code, broke it into a function or a procedure, and we're just doing stuff with it. That's it. And that's the whole idea behind procedural code. It's pretty simple. Functional programming is very similar to this, but we're going to get into that in a second. Object-oriented is the one that really differentiates itself, and this has been a hot topic for 20 plus years. It's definitely a good thing to understand how it works, because we're still in that phase where this is the thing, like this is how you code things, is using an object-oriented language. And most of the languages you've seen me mention so far are going to be object-oriented. And this is a list of 5. It's not the only ones by any means, but Java, Python, Ruby, C++, and C# are on here. JavaScript is kind of object-oriented. It allows you to do things, but it's also different in a way, so I did not list it here. But it allows you to write object-oriented code, and you're going to see that here in a second. But the idea behind object-oriented code, it probably sounds very vague as well, but the idea behind it is that you break your code into objects, which still probably sounds super vague. So objects are these combinations of two things normally. You combine procedures, which we kind of already know what that is. It's just a function of some sort. And we combine, objects are a combination of procedures and attributes of some sort. And that's the new one. And we're getting into what that means here in a little bit. Actually, right now. So let's look at some object-oriented code, and we're going to look at how you actually can turn this code right here into object-oriented code. I'm going to try to open this up in another panel. There we go. You kind of clips off the end here. Let's see if I zoom out for a second. Will that? Okay. Is that still pretty legible? Can you guys read that? Okay. If anyone wants me to zoom in, I'm more than happy to. So the idea of what we're doing here in the procedural side is we just have a list of some sort, an array. We are calling a function that's going to iterate through that array. Well, in object-oriented code, what we're going to do is we're going to define what's called a class. And a class is how we will create objects. A class is kind of the blueprint, and it's where you define, it's where you're going to define how your objects work. And in a class, you're going to define your attributes, which are just going to be properties of this class. And then you're going to also define your functions or methods, which are going to be the things that the procedures that exist on this object. So again, it's kind of similar to what I mentioned over here on procedural coding. The function never got called until we actually invoked the function. Same thing with the class. Even if we run this code from top to bottom, this class, nothing's going to happen here because we're not calling anything. It's not until right here where we're saying, all right, we're going to create a variable that I'm calling object, and we're going to do that using this new keyword. That's a very common thing. Whenever you see the new keyword, that usually means you're creating an object out of a class, and this is the class name right here, demo. And that correlates directly to what I named this class up here. So whenever I say new demo, what's going to happen is I'm going to get an object back, and what's going to happen is whenever I say new demo, it's going to run this constructor right here, and that's a common phrase for object-oriented coding is the constructor. Whenever you create an object, construct an object, the constructor will always get called the very first time, and that's how you kind of initialize things. It's how you say what's going on right now. Before I do anything else, what's the first thing that needs to happen? And right here, we're setting this .list equal to the same thing we had on the code to the left, that list of 1, 2, 3. Now, when I say this, that right there is defining an attribute. What I'm saying is I want this object to have an attribute called list. I'm using the this keyword to do that, and I'm setting it equal to 1, 2, 3. That allows me to do a couple things, but the thing we're going to see later on is, and that's all that's happening right here with the constructor, is right now object, after this line, object is going to be an object, and it's going to have an attribute called this, an attribute called list, and it's going to have a property, or a procedure or method, whatever you want to call it, called print array. And that's why I can do this right here. I can say object.printArray. That's a method that exists on that object. So whenever I call printArray, it's going to function just like it did with our procedural code. It's going to call this right here. And this is the exact same code, but instead of saying list.length, we're calling this .list. Because a list right here, if I were to say list, it wouldn't know what it was. List doesn't exist in the current scope, is what that's called. But if I say this.list, then this is going to refer to my object itself, and because list is an attribute on our object, then it's going to know what I'm talking about. So this.list is going to pull up this list right here. I should have put a semicolon there. We'll save that. And everything's going to behave exactly like it did on our procedural code. We're going to iterate through this list 3 times, then we're going to print it out. Again, you'll notice I'm using this.list instead of list. And everything's going to behave exactly the same way, and when we run this code, you can see we ran basics.js above. I'm going to run object-oriented.js, and we get the exact same code because we're doing the exact same thing. We've just structured our code differently. This is now valid object-oriented code. And this is probably going to be the most confusing one of the 3. And I totally get it. They spend entire semesters reviewing this stuff in college classes. You know, three hours every week. It's not easy to understand, especially the first go through. But if you can grasp, and so object-oriented is something that if you're not fully understanding it right now, which I don't blame you one bit, I certainly didn't understand it in my first 10 minutes. I encourage you to Google it, because it is a thing that if you want to be a developer, that's going to get talked about, whether it's in an interview or more than likely on the job somewhere. Kind of understanding object-oriented code is a hot item. It's a big ticket item. So this right here, the big thing, just going back to this presentation, objects are just combinations of two things, procedures and attributes. Object-oriented code you can get a little bit deeper down the rabbit hole. That's pretty much my answer to everything programming related. You can get as deep down the rabbit hole as you want to. But in a nutshell, this is how object-oriented code works. You structure your code to where you can create objects that are just encapsulated with procedures and attributes. Now, the last area I want to talk about is functional programming. And like I said, this one's been around for a long time. It's rooted in mathematics. But it's really becoming popular lately. And the reason for that, and these are some languages that, honestly, I would not be surprised if you haven't heard of any of these. Haskell, Erlang, Clojure, and Scala. And these are the biggest functional languages too. There aren't a ton of jobs, especially locally, for these right now. And the big reason you might use a functional language is if you have to build an application that supports multiple users, and I'm not talking one or two, I'm talking like 1 or 2 million at a time perhaps, something where you need people to be connected for whatever reason. Object-oriented code and procedural code usually struggle with that. They're very good at organizing your code, but when it comes to performance, kind of like game development, native apps beat out the cross-platform apps. Functional languages typically beat out other types of programming when it comes to performance. Now, what does it actually mean to be functional? Let's see if I have... Okay, so I do have a little definition here. It's similar to procedural, but there are two big differences. And one of them is that functional programming emphasizes pure functions. We'll get into that in a second, because that's the more difficult one to understand. The other idea is you have immutable variables. That's a fancy way of just saying they don't change. So they're not variables at that level. They're just constants. So ideally in functional programming is kind of a theory, if you will. Languages will try to be purely functional, but they usually have some caveats. It's a very theory-driven language. Ideally, in a functional language, you don't have variables that change. You set it once, and that's it. The variable never changes. The other idea that we'll circle back to what it means to be a pure function. In functional languages, a pure function is a language that doesn't do anything. It doesn't have any state modifications, and what that means is you're not accessing data from sources that are outside of the function. You're not using variables that are just defined outside of the function. And let's go back to our. I'll close this out. This is a procedural example. It's not a functional example because right here I'm referring to list, which is defined outside of the function. That's a no-go in functional programming. List would have to be defined inside the function. That would mean we're modifying state that exists outside of the function, and you can't do that in functional programming. There's a couple caveats, but the big things are just you don't want to modify state. And if you have any questions about that, which I'm sure there's a lot of flags popping up, feel free to ask me. But let's see an actual example. So in functional programming, this one changed a little bit, so we'll take this one slowly. But again, just same thing with the other languages. All this code right here is not going to get run until we invoke the function. So we have a variable here. It's our same variable, nothing crazy. We're going to pass this variable into the list, into this function, print array, and that's how we're going to get it in here. So this is okay. We're not modifying state of any kind. We're not using variables while the list was defined outside of the function, it's being passed into the function. That's okay. That's an okay thing for functional programming. Let's skip this part for now. I'm going to come back to what this is. This is an example of recursion. We're just going to print out the first entry of this list whenever we call print array. And what we're going to do next is we're going to recall the same function we're already in, but what this does right here is it's going to pass in the same list, which is 1, 2, 3, but it's just going to take off the first entry. So instead of passing in 1, 2, 3, we're going to pass in 2, 3. Now, Why would I do this? We've been using for loops so far. Why would I do something crazy like call the same function? And this is called recursion. This is a thing in programming. It is common in many types of programming. It is highly common in functional programming, because in the functional programming, most of the time the languages don't have loops, which is probably weird because I said earlier that they all have loops. I should have said iteration of some sort, because this is a form of iteration. So in most functional languages, you don't have for loops, you don't have while loops. Those are kind of the biggest looping structures in programming. But you can get by without it by using recursion, which oftentimes, depending on how you do it, is a more efficient way to do things. So what we're doing here, I said we'll ignore this. I'll come back to this here in a second. But we're right here. We're calling print array, even though we're already inside of it. And that's okay. But we're going to call print array, and we're going to pass in the same list, but without the first element. So we're taking off 1. So we're going to pass in the list that's just 2, 3, a 2-item list now. So we're going to go here to print array, and list is now 2, 3 instead of 1, 2, 3. Now let's actually address what this is going on right here. Whenever you have a recursion of some sort, whenever you're calling your same function over and over again from inside itself, you're going to get in an infinite loop unless you have some sort of base case which will tell the recursion to stop. Because otherwise, without that, you would just keep calling the same function over and over again. So this is our base case. This is how we are going to tell the function, okay, we need to stop recursively calling ourselves because we've done what we need to do. So what we're going to call here is we're going to say if the list that we passed back is empty, then we want to just exit. We don't want to call any more recursion. And the reason the list will eventually become empty is because we keep printing out the first item of the list, and then we keep passing the list back in with 1 less item. So we started off with 3 on the first function call, 3 items in the list. The second time we called print array, we had 2 items in our list. The third time we call it, we're going to have 1 item, and then the last time we call it, it's going to be an empty list, and that's when this base case is going to fire. So we're going to have called print array 4 times at that point, and each of the first 3 times, it's going to have printed out the first item of the list, which was 1 the first time, 2 the second time, 3 the third time, and then on that 4th function call, it's never going to get to right here because we're returning from the function. That's just an exit. We're just exiting the function, and that's going to be it. So, and this is a complex topic. I totally understand. But if you delve into functional programming at all, you will learn about recursion, and it's fun. It's a cool way of doing things, even if it's super confusing right here. So let's actually run this, and you will see that it should be the exact same thing. We've done the exact same thing as we've done with the other files here. We've just kind of done it a little bit differently. We've done it the more functional way. This is kind of one of the reasons why I like JavaScript a lot, is because it allows you to write code how you want to. We've written JavaScript procedurally, we've written it object-orientedly, we've written it functionally, and that's really cool that we can do that with JavaScript. Some languages will require you to write things only object-oriented. That's one of the reasons I like JavaScript, is you can really build it however you want to. Again, some developers may hate that. That's the end of everything I want to talk about, but I have one final thought, and that's just when you're building things, it's really, especially as you're kind of learning new ways to do things, it really gets tempting to want to build things in a cool way or a complex way or some way that only you really understand it, and if you wanted to explain it to someone else, you'd have to really deeply explain it, and that might make you feel powerful, and that kind of comes back to the job security idea. That may give you some job security, but the best way to be a good developer is to keep things simple. The best code that you can write is the code that I can read, pretty easily, and that I can jump into and actually help contribute. And that doesn't mean that you're doing easy things. All these examples were relatively simple. As you become a developer, you're going to be doing more complex things than this, but there is a way to write code and keep it simple. And that doesn't necessarily mean, I'm not talking only about how you write your code. I mean, if you are writing code that you want to put on a server somewhere that's going to call out, that's going to keep things in containers that are all doing their own unique things and have their own databases. I'm saying a lot of words now. But if you can do all of that stuff I just said with a single application running on your computer or a server somewhere, that right there is a good way to be a good developer. You don't need to be overly complex just for the sake of being complex. Keeping things simple is always the best answer to probably everything in life. Write that down. So that's all I got. Again, feel free to ask me questions. Either I think we got about 5 minutes left, but if you have any personal questions for me, feel free to ask. Here's some of my information again. That's my Twitter handle, the Code Boss. And then I am a blogger. I haven't blogged in a couple months or so, but I'm getting back into it. And that's thesociety.org. I'm a big T guy. All right, that's all I got. Yeah.
When you're learning these languages, when you pick one that you want to go with, you think will be the best for what you need to do, you stick to that strictly because if you go back and forth, is it really confusing, like the way you call them variables and different things? You use a lot of.
You really don't. And this kind of goes back to you Google all the things. You know, I use JavaScript a lot at my job, but sometimes I'll segue into Ruby or PHP as well. And you know, I just haven't messed with those languages very much. So I will Google up how to do these things. But then when I see it, it's like, oh yeah, that's how you do it. So it's yeah, and that's largely what messing with a lot of different languages is syntax differences. I will say that learning your first language, like JavaScript, for example, will always be your toughest language. Once you kind of understand that, there's just so many things that are common across all languages. I just realized now I didn't repeat the question, and now I don't remember what the question was. I'm sorry, Twitch. But your first language will always be your toughest, but once you start off that, it gets much easier. And it really doesn't get confusing. But again, you Google all the things. That's what it means to be a developer. Yeah. I started in kind of high school. I took a Visual Basic class. You'll notice that language was. The question was, how did I get started being a developer? I learned it in high school a little bit. I wanted to be a game developer. I had a teacher who was very bad at teaching Java the next year. She crushed my dream, made me feel like I was a bad developer. I was required to take it in college, and a teacher showed me I loved it, and then that kind of ignited the fire. But being a developer, you know, you can get all the classical education you want to. The vast majority of everything you do will be self-taught. That's just how it is. So for those of you, if you haven't done classical education, and if you didn't go to school for CS, you are at hardly any disadvantage compared to anyone else. If you go to school, you will learn things like data structures, and you will learn object-oriented code, and you will learn C and Java, but those are things that you can easily, not easily the first time, but you can teach yourself outside of school, and when you do that, then you're at the exact same point as people who have been classically educated. So just wanted to have that little caveat. Okay, I think did I see another hand up?
No, same question.
Okay.
There's a question on Twitch. When you're working on code with coworkers, is Git really the best way to collaborate? Seems like it'd be a ton of minutes every week to make sure you're in the same room.
The best way to collaborate is whatever your place of employment uses. Git, I'll repeat the question even though it was on the code. The question was, what's the best way to collaborate? Is Git the best way to collaborate? And the answer is whatever works for your company. Git is, and as far as version control, Git is the most common, and it is ramping up. But I work with a client right now that uses one called Subversion. It's SVN for short. That's an older one, and again, you know, that I sure would love to use Git instead of that, but I just don't have that option. So it's kind of more about, you know, what your company is using. There's other things besides Git. And if your company doesn't use version control at all, then that's a talk we need to have. We need to get them on version control. And it's different, you know. If it's just you, then you know the fire is not that. It's not super important. You still should be doing it, but it's something to learn, and I get that. But if you're working with 10, 20, or 100 other people, you need to use some type of version control. And Git is, in my opinion, it's the most popular right now. So just as far as support goes. I like it the best. Yeah.
So you mentioned you spend maybe an hour not coding, about 7 hours actually coding. How do you deal with burnout? I find myself on great days, 7, 8 hours of productivity. On not so great days, 5, 6 hours. Probably around 5.
Mm-hmm.
Are there any techniques or tools that you personally use to keep yourself from burning out?
Very good question. The question was, I'm getting better about this repeating thing.
3 hours.
The question is, how do you handle burnout? Because 7 hours does seem like a lot of time. And when I kind of say 7 hours, I don't mean that I'm, you know, headphones on, digging in. I mean, I'm coding, and then maybe a coworker walks in and I make fun of him because that's what I do. Or we talk about, Reddit or the latest cat gifs. But yeah, I kind of keep that all in the same thing. My big thing is I don't really do a ton of coding on the side. Work is kind of my big thing. I'm certainly interested in technology and in learning things on the side, but I really spend most of my time playing video games and other not programming things. So that helps. And then my big thing for in the work environment is it is very important for you mentally to kind of not be doing the same thing over and over again. And that's job specific. My last job, I loved it. I was there for 2 years, but I was building mostly static web pages. They had a content management system behind them like WordPress, but that was what it was, and that was awesome. I learned a lot of things, but it just got to be too repetitive for me, so I got another job. And my current one, the projects are changing, every few months or so. So that's the big thing, is to kind of just to keep learning things. If you're not learning on your job, then that is a problem. And I don't mean going to class or doing like education on school things, but if you're not presented with a challenge that you're having to actually figure out how to solve, then you've either one, become the best developer in the world, or two, that's kind of where you might think, maybe there's something else I could be doing right now. I don't know, but that's my opinion. I also play ping pong. We play games. It is important to take a break every now and then for sure. There's timers called I think it's like the Palmetto timer or something, Pomodoro timer, where you work for 25 minutes, take a break for 5 minutes, I think is what it is. I haven't done that, but I know a lot of people do. It's what works for you. I do want to say too that we're at 3:02. I'm good with answering questions in this environment, but if anyone's got to go, I'm totally cool with you jetting. What's the norm? Do we usually stop right at 3?
Let's go ahead and stop the stream if there aren't any more like big pressing questions, and then we can figure out.
Okay. That sounds good. All right, well, I'm going to stay here, but thanks again, everyone, for coming. This was awesome.